An even more sophisticated approach for decision making is using probabilities. Now, let's say there are these three decisions, and there is the two states of nature where whether you may have a competitor or not have a competitor, and this payoff table is given. Now, let's also say that there's a 60% chance that the competitor will begin offering electric scooter services in Chester City. Now that means that there will be 60% that this will happen, whereas the other 40% will be the chance that there won't be any competitor. Another way to say this, it will be the probability of this is p equal to 0.6, whereas the probability for this would be 0.4. Now, there's something called the expected value for each decision, and the expected value is defined as the sum. I know a lot of people become afraid when they see this sigma sign, this Greek letter, but all this means you add things up. You're going to add the outcome times the probability. Now, it's probably easier to understand what I mean if you see an example. So the expected value for decision 1 is the following. First, there's the outcome of 5, and the probability of that outcome happening is 60%, or 0.6. We multiply that probability. Plus, the next outcome is 5, and that probability is 0.4. Just like this, you multiply the outcome by its probability, you add them up. That's called the expectation value. In that case, you get 5. Because this will be 3, and that's 2. 2 plus 3 is 5. The expectation value for D2 is 3, and that has the expectation value of 0.6, plus 9, that has the expectation of 0.4. 3 times 6 is 18, so this first one is 1.8, plus 9 times 4 is 36, so it's 3.6. Adding these two, I get 5.4. Expectation value for decision 3 is -1 times the probability plus 12 times the probability. That's -0.6 plus 4.8, and that's 4.2. So after this calculation, we see that the decision 2 has the expectation value of 5.4 million. Now, let me explain what this means. It means that suppose the company was facing such a decision many times, and then there is something called the law of large numbers, which says that if you repeat a certain event many times, then the outcome will be closely following the probability. So if the company faced 100 such situation, then out of 100, about 60 times, close to 60 times, it will be with competitor, and close to 40%, 40 times, it will be without competitor. Of course, it sounds a little absurd in this case because it sounds like just a one-time thing rather than this happening many times. But if the company had many other decisions and it always went with the expected value approach, on the average, it will be choosing the best outcome. So the way that the company is making use of probability here is that if it does this many times, it will reap the benefits of the probability. Actually, financial companies do this a lot when they try to buy stocks or sell options and stuff like that. They always calculate the probabilities. They do this many times. So for individual stocks or options, they may lose money, but on the average, since they're using the probability, at the end of many of these decisions, they end up making money. Alright, so that's called the expected value approach. You calculate the expected value and you look at the highest number, and in this case, this wins. This has the highest expected value, so expected value approach will be choosing D2, and therefore the answer will be D2 increased by 20%. Alright, now let me tackle a slightly harder concept than just the expectation value. There's something called EVwPI, and this means this is expected value with perfect information. On the other hand, EVPI means expected value of perfect information. But I still haven't explained what it means, so let me start with expected value with perfect information. So, expected value with perfect information assumes the following. In the future, not now, in the future, like almost right before you make that decision, you get a hold of that perfect information. Now, if that happens, what is the expected value of your profit right now? Now, again, expected value, it's still expected value. It still follows the formula that you should multiply the outcome times the probability, right? So let's think about the two cases. The S1, when there is a competitor, the probability is 0.6, and without competitor, the probability is 0.4. Now, if right before you were supposed to make the decision, you learned that the competitor did join the market, right? Which decision are you going to make? You're going to make, of course, you would go with 5 if you knew it, right? And therefore, the probability that in the future you're going to make that decision to go with 5 will be 0.6, because that will be the probability when the competitor will join. Now, on the other hand, the probability that there won't be any competitor, that's 0.4, and in that case, you would go with 12. Because, of course, you know that there is no competitor, so you expand your business and you make more money. So that's what you will do. Right now, you don't have the perfect information, so you can only find the expected value of your profit. Okay? So this is the EV with perfect information. And in that case, the future is very rosy, right? 5 times 0.6 is 3. 12 times 0.4, that's 4.8. So you get 7.8. So on the average, you don't know what's going to happen. You may end up winning 12 million, or you may end up winning 5 million profit. You don't know which will be the case right now, but if you know that you're going to get a hold of that perfect information in the future, you will end up with 7.8 million profit. Okay, so that is the EV expected value with perfect information. What is expected value of perfect information? Well, this is about how valuable the perfect information is. And it's defined as EV with PI minus EV without PI. Now, what is EV without PI? Well, that's just your EV of EV approach. So it's this number here. It's 5.4. Remember, expected value approach was D2, and if you go with D2, you would end up with 5.4. Now, this is the case when you're not gonna know before that event happens, and you just make the best use of the probability right now. So you go with D2, and you're gonna end up with 5.4 on the average. 5.4 is your expected value of your profit. But that is without perfect information. So that's why it's called EV without perfect information. We found out that this is 5.4. And EVwPI, we found that this is 7.8. Subtract them, take the absolute value, and now you have 4 and 2.4. Okay, 2.4 million. So, depending on whether the company has perfect information or not, there's a difference between $2.4 million. This difference, the difference between expectation value with perfect information and expectation value without perfect information, is the value of the perfect information. If there's a way to get the information, how should you value it? Sometimes to get that perfect information, the company has to hire market researchers. It might contract out other analysis firms to get perfect information, or it might even hire industrial spies. And the value of how much money it should invest is given by the EVPI. So here's an example. G is a nice example here. Niels Wheels is looking into paying a private investigator to find out whether the competitor will be doing business in Chester City or not. What is the maximum fee the company should be willing to pay for the service? Well, what is the expected value of the perfect information is 2.4 million. The difference between having the information or not having the information is 2.4 million. So although it sounds ridiculously high, the Niels Wheels should be willing to pay up till 2.4 million. Well, actually, since they can't fully trust this private investigator in actual practice, they'll probably end up paying much less. But when the private investigator says, "Oh, I have access to this company, just give me like $2 million," well, they'll have to seriously consider it because it's less than the value of the EVPI.